A plane, or curved surface mesh can be generated by revolving curves for a specified angle, about a central axis. This is also a type of sweeping mesh generation. So, we have to define the source curves to revolve, and the central axis. Let's first define the source curves. Press the Curve tool and input the control points of a spline curve. Click the last point twice to complete inputting. Select the curve, and divide it into 20 segments. Choose Revolve Surface item from Mesh menu. Revolve Surface dialog pops up. Set the element type, triangular arrangement, axis setting option, and so on. The angle of revolution is set as 360 degrees. Change the number of divisions to 40. The spline curve is already selected as the source curve for revolution. Thus, Set Curve button is in active state. Click the button. Then, the caption of the button is turned to Set Axis, and the button is deactivated. It suggests that the central axis of revolution should be set in the next step. The option of setting the axis is currently chosen as Input. This implies that the axis of revolution should be specified by directly inputting the axis. Create a straight line, which will be automatically applied as the axis of revolution. Once the straight line is completed, Set Axis button is activated. Click the button. Then, a surface mesh of revolution is generated as specified. The next example demonstrates mesh generation by revolving multiple number of curves. Press Elliptic Arc tool. Select Quarter option item from the pop-up menu if the current option is not set as quarter. Create a quarter elliptic arc. Press Straight Line tool and create 4 straight lines. The elliptic arc and 4 straight lines are forming a closed loop. Choose Divide item from Divide menu. Curve Division dialog pops up. Set the number of divisions to 30. Check Apply as a whole option. Select all the curves by rubber band. Click Divide button. The selected curves are divided into 30 segments as a whole. Close the dialog. And choose Revolve Surface item from Mesh menu. Revolve Surface dialog pops up. Set the element type to 4-node quadrilateral element. Angle to 180 degrees. Division to 10. Select the curves, and click Set Curve button. The source curves for revolution are now designated. The caption of the button is turned to Set Axis, and the button is deactivated. The grid is turned on, so that the axis can be inputted using it. Create a straight line for the axis of revolution. Set Axis button is activated. Click the button. Then, the mesh is generated. The view is being rotated to obtain 3-dimensional representation of the mesh. It should be noted that the newly created surface mesh is treated as a single object. This can be confirmed by using the Surface Selection tool. Click the mesh. Then, the whole part of the mesh is selected as a single object. However, it may be more desirable to make the mesh composed of multiple objects. This can be achieved by a different process of mesh generation. Let's delete the mesh first. The source curves are retained as before mesh generation. Regenerate the mesh by revolving each curve independently. Choose Revolve Surface item from Mesh menu. Revolve Surface dialog pops up. Use the same settings as before, except the option for axis setting. Change the axis setting to Last. So, the axis used in the last mesh generation will be applied automatically. Select the elliptic arc, and click Set Mesh button. A curved surface mesh is generated. Repeat the same process for the rest of the curves, that is, the remaining 4 straight lines. It is not necessary to designate the axis of revolution, because Last option is applied. The mesh is completed. Let's check how the mesh is composed of. Close Revolve Surface dialog. The Surface Selection tool is automatically activated. Click a part of the mesh. Then, we can confirm that each part of the mesh is separated. Lastly, let's examine the cases with the axis of revolution, crossing, or touching the source curves. For this demonstration, a straight line, and an elliptic arc will be used, as the source curves. Revolve surface, dialog are prepared in advance. 4-node quadrilateral element, input, option for axis setting, 180 degrees for the angle of revolution, and 8 divisions are designated. Select the source curves, and click Set Curve button. The grid appears for inputting the axis. Input an axis crossing the source curves. Click Set Axis button. The mesh is not generated. Instead, there appears a message, Invalid axis of revolution crossing the source curves. Let's examine the case with the axis touching the source curves. Create the axis passing through the end points of the source curve. Click Set Axis button. Then, a new mesh is generated. Close the Revolve Surface dialog, and rotate the view for 3-dimensional representation. 3-node triangular elements appear to surround the axis of revolution, although 4-node quadrilateral element is designated as the element type in the dialog. This indicates that 2 nodes are collapsed to 1 node at the point of the axis. Press Surface Element Selection tool. Click an element. The element information shows that the selected element is 4-node quadrilateral element. On the other hand, the information of the element surrounding the axis reveals 3 nodes only. This is the end of the tutorial for mesh generation by the method of Revolve surface.